Good day. This is Bennett, also known as Jeremiah. Today we're going to talk about 4 essential skills that a student must have in general solutions. If you want the playlist of general solutions, both grade 11 and the grade 12 playlist, it is found at the end of this video. It is also found right here on the top right of the screen at the suggested video. So, let's begin. Alright, let's start here. So, we're given this particular stuff and we're asked to find the general solutions, right? So we're asked to find the general solutions. So, notice when you look at this, we've got sine squared and sine. Every time you've got sine squared and sine, or cos squared and cos, or even tan squared and tan, this is just like having x squared and x, right? So, whenever you've got x squared and x, it's quadratic, right? So, same thing in trigonometry. So, you are most likely to have quadratic equations. They come out a lot, right? They come out numerous times in past papers, right? You find them in general solutions, you find them in identities, you even find them in question street graphs, right? So whenever you have got sine squared and sine, this is quadratic in trigonometry. So you can solve it normally like quadratic, or if you want, you can even use the K method. To use the K method, we'll say it's not a must. You can even use the K method on the side, but it's not a must, right? So we can say let sine. So notice we've got sine squared and sine. So you take the smaller one. You say let the smaller one be equals to K. So if this is K, this is going to be K squared. So we're going to end up having 2K squared minus 3K plus 1, right? So this is equals to 0. So we factorize normally. So if you want to learn how to factorize if you want to pretend as though you factorize, I put the link on the video above, right? So also if you want to learn the actual way to factorize, you'll find it at the end of this video. So let's say we've got this stuff. So now the answer is going to end up being 2k minus 1 and k minus 1, right? So this equals to 0. All right, so now notice that I said let sine be k, right? Meaning that wherever I see k, I can put sine x back, right? So it means that this is going to be 2 sine x, right? Instead of 2k is now 2 sine x, then this minus 1, and then here instead of k is sine x, right? So I've just written it back. So you can use the K method, or you can even factorize this without the K method, right? So there we have it. So now we have this stuff. So now we're going to, okay, let me just erase this. So now we're going to find, so let me just write it over here. All right, let me write it over here. So this is going to be 2 sine x is rather minus 1. Then we're going to have sine x minus 1, right? So this is equals to 0. And then this is going to be 2 sine x is equals to 1, okay, not negative 1, but 1. So let me just do that. So 1, or sine x. So we're going to have sine x is equals to 1, right? So now here when I divide both sides by 2, my final answer of this particular portion is going to be sine x is equals to 1 over 2. So we've got two answers here, right? So whenever you've got two answers, you are more likely to have two pairs of general solutions. So before we get the general solutions, let's first get the reference angle. So what you will do is that you press arcsine, right? You find out which angle gives you half, right? So you press arcsine half, right? So arcsine half, sine 30 is what gives you half, right? So it means you say reference angle here is equals to 30. And then here your reference angle, what gives you 1? Sine 90, right? So you're going to say your reference angle here is 90. So let's revisit the formulas. Let's visit the general formulas. Before we continue, let's talk about memorizing the general solutions. So there are two different methods. I use this method, which is much easier. So whenever it comes to sine, you'll always say reference angle and 180 minus reference angle. The reason why we're doing this is because sine is positive in the first quadrant and in the second quadrant, right? And we're always going to have this k 360, and we always have to tell them k is an element of integers, or else we'll lose the marks, right? So sine is positive in the first quadrant, so it's reference angle, and it's also positive in the second quadrant, which is 180 minus reference angle. So let's talk about cos. So when it comes to cos, where is cos positive? We know that cos is positive in the first quadrant and in the fourth quadrant, right? So the thing is that this 360 minus theta can actually be written as negative theta, right? Why negative theta? Because notice that when we go this direction, it's positive. When we go backwards, it's negative, right? So in other words, negative theta is in the fourth quadrant. So instead of us writing 360 minus theta, we can actually write negative theta, right? So this is why whenever you see cos negative theta, you will see that the answer is actually positive instead of negative, because negative theta is in the fourth quadrant and cos is positive in the fourth quadrant. So instead of us writing 360 minus theta, we can just write negative theta. So now notice that it's positive in the first quadrant, which is reference angle, and it's positive in the fourth quadrant, which is minus reference angle, right? Instead of saying 360 minus reference angle. However, we do not need to write the two equations separately, right? We could just combine them into one. So that's what they did here, right? So we can just say plus or minus reference angle because it's positive in the first quadrant, which is reference angle, and positive in the fourth quadrant, which is minus reference angle. So whenever you say cos, you can just simply say plus or minus reference angle. It makes things easier. So let's talk about tan. Now where is tan positive? Tan is positive in the first quadrant, which is theta, and in the third quadrant, which is 180 plus theta, right? So first of all, I want you to notice that the period of the tan graph is 180. So it's not 360 like sine and cos. So whenever it's sine and cos, we always say K360. But when it's tan, we always say K180. So this can be forgotten by professionals, right? Even by professionals. So even I used to forget this, right? So another thing I want you to notice is that we only have one equation. Why do we not have two equations? Notice it's positive in the first and the third quadrant. So we're supposed to have reference angle plus K 180, and we're also supposed to have 180 plus reference angle plus K 180, right? But why do we have one equation? The reason why we have one equation is because this has a short period. Because it has a short period, it gives you the same answer as the other equation. So there is no need to write the other equation, even though it's correct. You're just wasting your time, right? Writing the other equation is like writing the same equation again because it gives you the same answers when you substitute in place of K. So every time you've got tan, it's very simple. All you have to do is just to write reference angle plus K180 and you're done. Alright, just in case, you might be wondering, what if your reference angle is negative? So let's just say you are solving for sine and then you type arcsine in the calculator and you get your reference angle as negative 30. What do? If your reference angle is negative, the nice thing about these formulas is that nothing changes. So if your reference angle is negative, if you're dealing with sine, you'll still use these formulas as they are, right? The only thing is that if you get negative 30, do not ignore the negative, substitute it as it is into the reference angle. So I would advise you to pause the video and memorize these formulas, right? And we're going to use them in the following questions. So let's talk about the equations. Whenever it comes to sine, it's always going to be x is equals to reference angle plus k 360, right? And then you always tell them that k is an element of integers. So this is the first equation. Cos is positive in the first quadrant, right? It's also positive in the third quadrant. So in the third quadrant is rather positive in the second quadrant, right? Which is 180 minus reference angle plus k 360. And then k is an element of integers, right? So our reference angle was 30. So you're going to say x is equals to 30 plus k 360, right? K is an element of integers. And then here it's going to be x is equals to 180 minus reference angle, which is 30, plus k 360. And then k is an element of integers. Let me just write that part at the end. So notice that here 180 minus 30 is 150. So our final answer here is 150 plus k 360. And then we solve them. K is an element of integers. So these are your two general solutions, right? So here we go. So these are the two general solutions for this particular angle. But now, because we've got two answers, we're going to have two pairs of general solutions. So we have to get another two. So here our reference angle is 90, right? So our formula is x is equals to reference angle, right? So reference angle is 90 plus k 360, and k is an element of integers, right? So k is an element of integers. So the second one is 180 minus, right? So now 180 minus 90 is 90 again. Because notice, if we say 180 minus reference angle, which is 90, it's going to give you 90. So it's the same answer as this. So there is no need to write it twice. So this is going to be our final answer. So we've got 3 equations. So whenever you've got 2 pairs of answers, you are more likely to have 4 equations because 2 will come from each. Sometimes you can have 3 equations, sometimes you can actually have only 2 equations, right? So this is the first part. Whenever you say quadratic in trig, you have to factorize it in quadratic, right? You have to factorize it using how you factorize quadratic equations. Let's go for the second example.
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in math or whether it is the situation where you're good in math but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
Alright, here is another example. So we're given this particular portion. So when you observe this, this is normal quadratic because we do not have sine squared and sine or cos squared and cos or tan squared and tan. So what do we do here? Notice that there is actually a common factor, right? So notice that we've got 2 terms, right? These are 2 terms, 1, 2, right? So we've got 2 terms. So whenever something appears in all terms that we have, then that's a common factor. We have to factorize it. So notice that sine appears here, so we're going to factorize sine, right? So we only do that if this is equals to 0, right? If it's not equals to 0, then we have to use another technique, right? So notice that this is going to be sine, right? Then when we divide this term by sine, so 2 sine x cos x divided by sine, sine will cancel out, right? So we'll only be left with 2 cos x. And then this side we have got negative root 3 sine x divided by sine x. So sine and sine will cancel. So we'll be left with negative root 3. So this is what we have. Then this is just like algebra. So now notice that sine x is equals to 0, right? Or we have got 2 cos x is equals to root 3. So warning, if this was not equals to 0, if this is equals to 1, do not say sine x is equals to 1. You can't do that. You can only do that when it's equals to 0, right? So whenever you have factorized, you cannot equate this to the number that is here unless that number is 0, right? I can explain it more in mathematical way, but there is no need. Just memorize that whenever it's not equals to 0, you can't say sine x is equals to that. So let's continue. So now here, before we get our reference angle, let's just get this part. So here, when we divide both sides by 2, we'll end up having root 3 over 2, right? So our reference angle here, what gives us 0? Our reference angle here, sine 0 is 0. If you type arc sine 0, you'll still get it as 0, right? So 0 degrees gives us, so sine 0 degrees gives us 0, right? So here, if you type arc sine, right? So what gives us, cos what is root 3 over 2 is cos 30, right? So with the calculator or without the calculator, you should get 30, right? So now you've got your reference angle. So when it comes to sine, sine is easy. Remember, sine is reference angle plus K360, right? Or 180 minus reference angle plus K360. Okay, so I realized that I didn't put K over here. Let's just do this. So let's just put K, so K360. So x is equals to reference angle plus K360, or x is equals to 180 minus reference angle plus K360. So notice that it's 0 plus, right? Our reference angle is 0. So 0 plus K360. So you do not leave your answer like this. 0 plus K360 is just K360. And if you check in the memorandum, you'll see that it's going to say x is equals to K360. Literally. And then this particular portion is going to be 180 minus 0, right? Plus K360. But 180 minus 0 is 180. So we do not leave our answers like that. Here you are more likely to not leave your answer like that. So notice that. I'm sure this one you already know, right? You can't leave your answer as 180 minus 0. So this is going to be 180 plus K360. So there we have it. So this is what we have. So your final answers for the first, for the 0 portion is k360, right? X equals to k360, or x equals to 180 plus k360, and put k as an element of integers, or else you miss the mark, right? So there we have it. So that's for the first portion. All right, so now our reference angle is 30. When it comes to cos, the formula is more easier, right? The formula is just plus or minus reference angle. When it comes to cos, the formula is plus or minus reference angle plus k 360, right? K is an element of integers. So then this is going to be plus or minus 30, right? So plus or minus, okay, so I just erase this. Let me just reverse the process. So notice that it's going to be plus or minus 30, right? So plus or minus 30, okay, plus or minus 30, let's just remove that. So plus or minus 30 plus k 360, and k is an element of integers. So we're done. So when it comes to cos, it's simple. Just one equation that says plus or minus reference angle. So this is only for cos, right? And we just put our reference angle and we're done. So this is our general solution. So let's go for our final example of this video. Alright, here is another example. So you're given this particular equation and they ask you to find the general solution. Just before we continue, if you're interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details, just in case these ones have changed, is found at the end of this video. So what do you do in this case? Every time you are given sine and you are given cos, if there are numbers in front, you have no choice but to turn it into tan. So how are you going to turn it into tan? So what you're going to do is that you're going to first take this to the other side of the equation. So then this is going to become, sine theta. So we're going to have sine theta. Let me just do this. So we're going to have sine theta is equals to root 3 cos theta. So our goal is to change it into tan. So there are many ways of doing this stuff. So we took this to the other side of the equation. So now we've got sine theta is equals to root 3 cos theta. So what are you going to do? So this scale is very important. It comes out a lot in both grade 11 and grade 12. So we're going to divide both sides by cos. So you are dividing both sides by cos so that it can become tan. So this is going to be all over cos theta. Now notice that these two cancels and sine over cos is tan. So eventually we've got tan theta is equals to square root of 3. So let's find out. We have to find the reference angle. So what gives us square root of 3? So what gives us square root of 3 is tan 60. So the reference angle, okay, so I wanted to write theta is equals to 60, but it's better to just say the reference angle is equals to 60. So when it comes to tan, the nice thing about tan is that we only use one equation, which is x is equals to, so it's going to be reference angle plus k180, literally. Okay, so I nearly wrote 360, but it's k180. So it's going to be k180, and we have to tell them that k is an element of integers. Okay, so this is how it is. So this is the equation, so let's substitute. So we're going to have x is equals to 60 plus k180, and that is it. K is an element of integers. So there we have it, only one equation.
Alright, we have reached the end of this video. I have included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.